Okay, lesson 53, power rule for exponents and conversion of volume. Remember how I said in the beginning of the year that exponents were going to get confusing? Well, here's where we add another confusing piece to it. We've talked about adding exponents. When the bases are the same, we add the exponents. When you're adding like terms, you don't add the exponents. Now we're going to talk about when we multiply the exponents, and we're going to be using the power rule for exponents, which says if m and n are real numbers and x, the base, does not equal 0, then x to the m to the n power equals x to the mn. So to play this out a little bit, if we had x to the 5th times x to the 5th times x to the 5th, we have learned that when the bases are the same, we add our exponents. So we would get x to the 15th. Another way to write x to the 5th times x to the 5th times x to the 5th is to say x to the 5th cubed. Now we know already that this answer is going to be x to the 15th, but you can see an easier way to do this is just to multiply the two exponents. So we would just take this is called a power to a power. This is the 5th power to the 3rd power, so it's a power to a power, and you're just going to give you 15. So let's look at a couple examples. Here we have x to the 5th squared, so power to power rule, you're just going to get x to the 10th. P to the -7 to the -7 power, power to power, so you get p to the 49th. And here we have m to the k power squared, you're just going to get m to the 2k. So far so good. We're going to run into some problems right away though in example 1. You can see we have a number that's not an exponent. See that? This tricks people all the time. See that? Okay, you're not going to multiply these two. You only multiply the exponents. So what you are going to do, though, is you're going to take the 3 to the -2 power, and then we're going to multiply our exponents. So we're going to get x to the 4th, y to the -10, all over z to the -8 power. Now, I'm not sure if the book is going to say where you should put the exponents, whether to make them all negative or positive. I don't think they're getting picky about that. But what you do have right here, this problem right here, is you can't bring a number to a negative power. So what you have to do is bring it into the denominator. So we're going to leave everybody else the same. X to the 4th, y to the -10, all over 3 squared, z to the -8. And then finally, this obviously is going to be 9. So we're going to get x to the 4th, y to the -10, all over 9z to the -8. Just be really careful with this. We're not going to multiply these two. We only multiply exponents. We raise the coefficients to the power, but you can't raise it to a negative power, so it has to go to the denominator and become positive. Let's try another one. Okay, same idea. We have 2 to the -5th power, so we're going to just write that 2 to the -5th. I am not going to write -10. Then we're going to get a to the 10th, b to the -10th, and z to the 50th. So we're just multiplying this times this, this times this, this times this. And your final answer will be a to the 10th, b to the -10, z to the 50th, all over, we can take 2 to the 5th power and get our 32. It'll be 2 times 2 times 2 times 2 times 2. Let's try another one. Okay, this time we have 4 squared, x squared, y squared, and we have a fraction this time. So we're going to do the same thing, power to power, m to the -4. And then your final answer is just going to be 16x squared, y squared over m to the -4. So I hope you're finding that these aren't that difficult. It's just going to be confusing when everything's mixed together. Alright, this is 2 to the 0 power. We know 2 to the 0 power is going to be 1 So we can just leave that 1. 1 to the 15th power would just be 1. X to the negative 30. Y to the 60th. Z to the 15th. And that's that. At first, you're just going to multiply, and it's not going to seem difficult. Alright, let's try the next part here. We're going to do unit conversions for volume. So hopefully you understood unit conversions. If not, it's a good time to learn. So this problem says use 3 unit multipliers to convert 180 cubic feet to cubic inches. So let's just hit this. So we're going to have 180 cubic feet, which is feet cubed. They want to use 3 unit multipliers. We'll start out using 3, and then we'll talk about a shortcut. And we want it to go to inches, so we need 3 inches up here. And we need enough feet to cross out with those 3 feet, so there's a feet, feet, feet. You need as many on the bottom as you have in the numerator so that they all cross out. So this is going to cross out with this, this, and this. You have 12 inches in 1 foot, 12 inches in 1 foot, 12 inches in 1 foot. So you're going to get 180 times 12 cubed inches cubed. And the book leaves it just like that. The other way you can do it is you can say 180 feet cubed, and then you could do your 12 inches over 1 foot cubed like that. And it will work out the same way. Let's try one more of these. We're going to use 6 unit multipliers to convert 800 cubic centimeters into cubic feet. So we have to go from centimeters to inches to feet. So let's do it the shorter way. We're going to go to inches. So we know that we want centimeters on the bottom so that they can cross out. We know that there's 2.54 centimeters in 1 inch. And we're going to be cubing this whole thing. And now we're going to go from inches to feet. The inches are on the top, so we need it to go in the denominator. We're going to feet. There's 12 inches in 1 foot. The whole thing is going to be cubed. So all the cubes, centimeters are going to cross out. So we're going to get 800 times, there's nothing else in the top, right? Except we're going to need our inches, or what are we going for? Feet. Cubic feet over 2.54, and that's cubed, and 12 cubed. And you can just leave your answer just like that. Just make sure you have your units on there. You can do it out in your calculator. I'm not sure what the back of the book has. So that is it for lesson 53.